Hello everyone, this is Saad Asnan Khan. I'm a master's student in ODU. My major is computer science, and this is my data science project that I'm presenting you now. So, reason selecting this topic. Oh, sorry, the topic is actually correlating. I'm actually correlating the weather data with crop yield and production performance. So, reason behind selecting this data or selecting this particular domain is I have a very uh, personal interest in this domain because from last 6 years I've been working to start my startup, and in my startup, like I've been working with some uh, crops exporters in Pakistan or in subcontinents. There are who actually they are basically export the crops or uh, agricultural goods to um, to US and Europe. So I was working with them to in some of the projects, like um, there is a project called they have a department, separate department to analyze the crops and their like qualities by looking into them. So I was working in identifying the quality of the crops by just visualizing the visual data that they have or we collect by asking them that what feature they look into the crop to identify the quality of the crops. So these are the projects that I have been working there, and now as I'm working in my data science project, so I decided to go with something related to crops, and I'll choose primary data as weather data, and I'll correlate. So another reason selecting this domain is like um, that it is obvious that weather and climate change has a very huge impact on crop yield and production performance. So the source from where I'm actually getting the data is a US agricultural website. They are rigorously updating the performance measure and the surveys of the crop yield and production and everything very rigorously, and they have a very good data collection. So this is the actually their website, U.S. Department of Agriculture, and if you can see into their website, they have many blogs you will find like agricultural in a changing climate, and so it is obvious that weather has a very huge impact on the crops and the agricultural parameters. So this is the website. They have actually a separate website. I've shared a link into this project report where you can see the actually you can see the source of data. So they have a like a developer portal which they have API system. So I used their APIs to gather their data directly from their data collections. So like if I'm going like selecting these um, crop data, so I will select the filters that they have here. I will select rice. So I'm in this project. I'm actually working on mainly the rice crop um, to make to make it a source uh, item for now, or you can say the main crop that I will be analyzing in this project. So if you can see that there are many categories or there are any parameters that they have been like updating here. If I want to see the yield, I will just select pound per acre yield by county, and this actually the data is so huge, so they have a very slow loading mechanism here. So once I am selecting the state and county, uh, I will be able to select the duration of which duration I will be needing. So I'll simply press get data, so I can get the data here in a tabular format, and I will have data like the yield per measured in pounds is 7,950 pound per acre, and it was in 2020. So these are the survey that I will be using, and I can also get this data in an Excel format, but it was efficient to use developer APIs system that they have. They have very good like APIs already developed. So I'll be using that. So it will be very efficient and it will make my work really easy. So I will be using Python to extract all the crops data. Then I will be simply uh, making a GET request and cleaning all the data that we have studied during the course. So and another secondary data that I will be using is weather history, and for that I will be using a Wonderground a website where I will be getting all the like uh, weather change and weather website. I will be scrapping this website because I was not able to find the actual weather data for like the counties Colorado and Arkansas. Actually extracting the data of two main biggest producer of rice in US. One is Colorado and one is Arkansas, and I'll be using the same like the same mechanism of scraping the data by using Beautiful Soap uh, library. The Beautiful Soap library does what it does is like will scrap all the data as an HTML, and using that HTML, using that DOM document object model, we will be able to identify the elements and getting the text from that elements and making a data frame and storing that data frame into a separate weather.csv file. So yeah, this will be like I'll be doing here. So I will be using this crop data as I will already tell you, like I will be using a rice data for my project, and because for this project we don't have enough time to do all the crops, but we will be extracting the weather data for last 30 years of Arkansas and Colorado City and using those the crop data for the same Colorado and like uh, Arkansas county. So these are the two main producer of rice in overall US. So I'll be using their data. Uh, and also the target audience. So the target audience of my project is like the commodity buyers and sellers, importers and exporters, and retailers. So, um, as I've already told you, that when dealing with commodities, quality measure plays a very huge role. Like for millers, they use these measurement to analyze the final product they want to produce, and they actually have a mechanism to check the the data, the sorry, the crops that they are receiving into the mills. They know that which at what time they should be ordering the crops from the farmers, and when farmers deliver the crop into the mill, they check the quality of that mill of that crop, and if they are up to the mark, like if the crop is up to their requirements, so they accept that order, or else they return back to the farmer. So it is a huge pain for both farmers and millers and exporters. So if they will not get a good quality crops, or if they will not get a good yield, So it is a pain for both. So to kill to make this yield performance and production performance more efficient, if we'll have a prediction model that will analyze and that will forecast, will show the forecast of the crop being like performing bad um, before, so they can take a necessary measurement to, you know, to 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 improve the performance, to improve the quality of this. And for the visualization, because I will be creating uh, like plots and charts. So for visualizing, I will be using Seaborn library. And data source, I will already tell you that weather climate, I will use the underground history website. So this website is really easy and simple and developed, and it don't have any complex UI. So that's why I decided to get the, data from this website. It has a very nice table, like for high temperature, low temperature, daily average precipitation. It means like the rainfalls and the dew and maximum wind speed. So these are all the parameters that I will be using. But some of them are like I will not be using, like civil twilight and nautical twilight. And I know that these wind speed and visibility will not affect the crop yield. So these are the huge parameters, affecting parameters that will be that is more like related, that can be correlated using. So and I've already showed the code, show the code of how I'm actually extracting the data from the U.S. Department of Agriculture website. They have an API system, so I will be using their API mechanism to extract the data. And they have some like issues in their data, then I will be using to use I will do some like filtering stuff and like data wrangling kind of stuff. So I'll have a clean object that will have air, county, country, type. So I will have a like good uh, table, a data set, so that I can work easily. The user interface would be like I will not be developing a whole website to show all these stuff. So it will be in the future scope. We will discuss it in future scope. So implementation, as I already told you that we have to go through some of the like uh, data wrangling stuff, because when I was scrapping all the um, uh, weather data, there were like some issues in the data that I have to go through. Let's say there are some null values, there was some false data, and there was some text in the numeric field. So like there were some time attribute as well in the data. So I clean up those as well, and end up cleaning the data, and I have a good data frame. In the end, I'm not currently saving these data to any database because it's a raw data, and I will be cleaning up those and using different mathematical operations to come up with the conclusion that how well I will be using this weather data. So for the, because I have weather data for each day, I have 30 years of weather data I've extracted from that website, Wonderground. And now what I will be doing, I will be converting these day by day data to actually monthly mean of average temperature and maximum temperature, minimum temperature, median, mode, standard deviation of the temperature. So I can be easily checking out the relationship of the data and the variance of the data overall. And plus, now we will move to data relationships. So at first, like I have done like separate data analysis. Like for 30 years, I will be checking that how much variance I am getting. So in 2018, you can see that there is a really high temperature recorded in this year in 2018. So these are some like um, uh, weather plotting, weather relationship that I plot to check the like the variance of the weather changing. So if you see this thing like per area variations, so you can see that um, every lines is basically different and intersecting other airs, other temperature levels. So you will have a clear idea that there are a lot of variation in weather each year. So this is the mean average temperature per month of each air. So each line is representing separate air. So you can see that 2011 has a very different anomalous data. Like it cannot be said anomalous. It can say like it can be clearly seen that there's a very big variation uh, in the month of June, 6, 7, and 8 month, like August, July, and June month. You can see is a very big variation, and and then again, once we have done with the separate analysis of weather data, we will move to the rice like rice yield per of Colorado County per year. Like if you can see that in 2014, 2011, it was like around 7,900 or something, and it was close to 8,000, and so data, the crop yield are also, crop yield are also not not persistent. It is continuously changing each year. So that is what we are going to see, that we will be relating these data to whether that how this yield, if this yield is actually like related to that data, weather data. So it is depending on the data or not. So this is the production CWT. CWT is a unit, so the value is actually divide by 100 to find out the actual production count in weights, 100 in kgs. So this is the rice production in CWT in Arkansas. So you can see that production is also changing. So and now what we will do, um, now we will make both once we have separate analysis of crop data and weather data, we will now relate these data uh, all together to check the like the relation between the crop of the uh, the weather and the crop yield and production performance. So before that, we have to do some more wrangling because if you can see that uh, in this reference side, I'm saying that according to United States, rice planting started in March and harvest done in November. So we will be calculating the average or mean weather parameters from the month of March till January and related to rice production and yield. So if you can see in this website, um, you will see that rice planting and harvesting actually began in March, and it ends on November, in the end of November, on the start of November. So it depends on different counties, but most of them are actually doing stuff in between March and November. So planting and harvesting is actually done in between these ranges. So that's why what I will be doing, I will be using these weather parameters between these months weather parameters and actually calculating the standard deviation and mean of them. And using that mean, I will not actually be using the standard deviation right now because I will be checking the mean relationship, uh, because if you want to find whether if you want to check the weather condition of air, like what condition of or related to weather have been in that air. So it will be good to first take out the average or take out the mean of all the days in a month, and after you get each month mean, you will get the monthly mean, collectively months mean for air. So that actual temperature or high temperature, low temperature, that you will can say that this for 82 Fahrenheit, we have recorded this air average temperature in this air. So once I have an authentic data, that so I can and will filter that air. I will be looping in airs like 1990. I will be gathering the data of weather, and I will be gathering the data from the crop data. And using these, I will be like calculating some uh, loss percentage loss. Actually doing like acre. If you can see that there is I have calculated a formula for percentage loss. So how I'm actually calculating the loss, it is when you planted 7,000 of the quantity and you harvested actually 6,000. So it means that you are not able to harvest 1,000 acres because they were not left. So it means that these crops are actually died or something. So it is my assumption that I'm calculating this acre loss, and and using that acres and planted, I will be calculating on the percentage loss of in that year, and I will be using yield pounds per acres in production CVT as we discussed before, and we will create a separate object for our analysis and further, and we will create a data frame for this object. Once we have done that, we will check the both really, and we will plot these data on the scatter plot to check the actual result that what we have. So if you search on the internet or that what actual the temperature is required, is it is good for a rice crop, so you will find out that uh, between the range of 65 to 80, it is said that it is a very good, um, you will get a very good yield and very good production in that year if the temperature is around 65 and between 80. So you will see that there are most of the uh, most yield most of the years yield are grouped here, and 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 this is the high temperature to yield per acre, yield pound per acre data. So you can see that this data is grouped over here mostly because so it is showing that uh, the temperature is required to get a good yield is around 65 to 80. So if you can see that extreme weather is extreme, in extreme weather, that they don't have a good yield. So good yield will also, you will also be seeing a good yield here and grouped together with other air crop production. So in average temperature and yield per pounds per acre, you can also see that all the data is grouped together in between the 60, and so these outliers is also telling you that no matter what, this high temperature yield, this high temperature air yield is not going to be here, because as I said that this cannot be the case that because high temperature yield will not produce maximum high temperature areas will not be giving a good yield. So outliers is also important in this data. So you can see that this data over here with have a high yield is only in the range of 60, in between the 60, and you can see all these data is also in the range of 65 to 80. So there are a couple of more plotting I've done, but I didn't find an actual relation, or there are relation, but I'm not sure that there are actually a relationship in this or not. So once I'm done with the like finding out the relationship that these temperatures and the weather condition are. So you can see that there are also some crop yield grouped together here in between the like mean dew point in between 50 to 60. Most of the crops are grouped together over here. Most of the yield are in between these. So for that, I'll be using the same data that I have generated for visualizing uh, the data, visualizing the relationship between these two parameters, and we'll use this to generate our machine learning classification model. So first of all, that we use to predict a crop's performance is simple. Use that data, and we will add it uh, using the. And also, we will what we will do. I will be doing to make the machine learning classification. I will need to classify the data with respect to the yield performance. So if you can see that I have calculated the yield, and how I'm doing that, because I have the data for per year for like yield per acre for 30 years. But how I will be actually you know uh, classifying that data, that it is good either or bad classification. So I'm gonna update the code as well, because I realized that this categorization is not actually updated. Okay, so this code is updated now. So what I'm doing, I was telling you that how I actually come up with the performance or the classification of the data is actually what I did the sampling. So why I need sampling? Because I don't know that what is the maximum yield that I will be having to check that if the current year is actually up to the mark. So what I did 10 10 years of sampling, and like if I have 30 years of data, I did sampling of 10 years, and each 10 years I get the maximum yield, and I'll divide the per year yield and multiply by 100, so I'll get the performance that if the yield is 90%, then it's excellent. If yields is between 70 to 90%, it's good. And if its yield is actually between 60 to 70, it's average, and below that is it is bad. So I use the same data that I use in creating the relation in visualizing the relationship between these two parameters, and using that data I created the same data, but I added a class yield and separated with like relationship data, and created a separate CSV of it. Once I have the CSV, I use Vika classification, Canaan classification model, Vika tool, and use k nearest neighbor classification, and place it using K1, K2, K3, K5, and K7. And I got 70% in K1, and when I increases the K K parameter, so it gives me 74% of correct classified instance. So I think it's like I came up to the point where I have a 70% of like my data can uh, create a prediction 70%. It is actually giving 70%. So I also used a binary tree which was giving me 89 percentage as well. I haven't updated it here because I was more focusing on the k nearest neighbor. So this is what I come up till now, and to check, to get more into that prediction, so I want to see actual data, if this code, if this model, if this classification is actually giving a correct result. I wanted to see the data, uh, um, data result, and what I did, I used the like evaluation categorization code of k-nearest neighbor using sklearn library. And what I did, I did I used the like weather data from like 2 to 20 columns. I have only rather than 220 columns. 20th column is actually the classification here. Why I needed two, I excluded these two parameters because I just want a numerical data for these years, and I will be checking the classification, class yield, like classification of that. So I'll be using the same 20% test size, like it will be extracting out test size of 20% of the data. It will be randomly giving out the test data every time I was running this. So what I did, I printed the test data here so I can go back into my Excel or a CSV and check the result if I'm getting the 70%, at least 70% correct prediction. So what I did, this is the training test data set that has been printed, and this is the result. This is the classification result that this is predicted for these test data set. So what I did, and actually, I don't know why Vika was giving me 70 percentage, because the time I have now not uh, I don't have enough time to go back and like check what I was doing. I guess I was doing the cross validations to 10. I need to like percentage split the test option to 20. So I guess it will come up to 83 percentage again. So the accuracy was 80%, and it was obvious because when I go back into the data, if you can see the accuracy 83%, and it has a variance each time when we run this. And also to be mentioned here, when I was running it continuously, it was giving me like 80 and sometimes 75 and 76, because of, I guess, it was doing the splitting of test set randomly. So when I go back to check the result, and it this is the data, like if you can see, like for 8612, 8612, it predicted wrong because it was classified as good and it was classified as excellent. And when I went to like 85.44, like the fourth one, 85.44 and 3.86, it's like 8544, 3.86, and it was excellent, and it was predicted correctly. And for the good, I have checked all these data, and that's why I added a screenshot here, so they predicted correctly these all the data. So uh, it did not predict it. It did not classify this one data. So it was pretty obvious because it is giving a 83% of accuracy. So the chance of error something. So this is what I have came up to till now, and I will be planning it to work in future as well because I have a very strong interest in this domain. So, summary is, we have reached the conclusion that weather and climate variance have huge impact on yield and production performance of the crop. By further working on different weather and climate change parameter, we can achieve the accurate prediction. So, it is giving currently like 83% of the predict accuracy. What I will be doing is I will just using the temperature and the precipitation, but I don't have actual rainfall data of that. So because using that rainfall data, it will be helpful to, because these crops irrigated using that rain data in the farms. So that will be a really good parameter for that as well. So I'll be adding a rainfall data and the pest control data. So in future, weather has very huge impact on crops. The data I have used in this project for the last 30 years of the crop performance. In future, I will extract the data of different crops. I have used rice in this project, but I will be using in future different for different crops. And also, uh, I will also be using other factors like pest management, irrigation parameters that I told you before. I'll be using those as well to come up the accurate prediction of the crop performance. And further on, I will be continue to working in this on this project personally, because this is not actually funded, or it is for my own interest. I will create a website using these technologies like Angular and something, and using a MongoDB in the backend to generate a complete website for like product owners of farmers and agriculture. So that will be a good website, and that will be a good initiative for farmers, so they can go ahead and check the like weather conditions, and actually how they can, they will be getting the the actual uh, or you cannot say like estimate, it's not accurate and right now, but if they will get a rough idea that how the crops and uh, how much yield they will be expecting in that year. So because I'm using March and till November data, so in December or in like in between November, they can also see that the weather condition is like that, and it means that we will be getting the yield and the production of this amount. So this is the overall project that I've worked in this semester, and I hope you guys liked it. So this is the first time I'm presenting my project like that. So if you guys have any other, or if you guys need to need more understanding on the project, you can contact me over my email address. You can see in this report, it's here, and then we can discuss it. Okay, thank you.